No, sir.
So, okay. So in the last class, we were seeing what? We were seeing SOP and POS form. Okay. So in today's session, we are going to continue the discussion. Okay. So where is SOP used? Where is POS used? We are going to see them one by one. Okay. So one thing I forgot to tell you. See, basically, it's okay. I will tell that in your K map. Okay. Now, there is one question over here. So, please tell me what will be the answer. Very simple question. So, we are going to start today's session with the questions only. See, look over here. For the identity, this identity given, the dual form is. So, dual form you need to find for AB plus A complement C plus BC is equal to AB plus A complement C. Okay. So, if I take dual, so I have already told you in dual, plus converts to dot and vice versa, and 1 converts to 0 and vice versa. So here you can see these are all dot and here it is plus. So this will be A plus B dot A complement plus C dot B plus C is equal to A plus B dot A complement plus C. So which option do we see? So option A is your correct answer. Okay.
Yeah.
Option A is what happened? Any doubt?
Yeah. Yeah. No, sir. Just a confirmation that sir, do we also need to simplify the expression if it's needed?
See, if they are asking dual, okay, if they are asking you dual, this is in which form? This is in SOP form. So dual of SOP will be POS. So you don't need to solve it once again, because if they are asking you in SOP format, so obviously the dual will come in your POS form. Okay. So if you solve this expression also once again, by opening the brackets, you will again get this expression only. Okay, you will get this expression. You can do that. You will get this expression from where we had started. Okay, so there will not be any change. So no requirement of doing further simplification. Okay, if your options are matching, then it's okay. So the next question is, for a 3-input logic circuit shown below, the output Z can be expressed here. So this is a 2017 question. Very quickly tell me what will be the answer. What answer did we get? Don't look into my solution. Okay, so I had solved that to save time. Okay, so that we can save few minutes. So what answer did we get? This is a very simple question. You can see here we have what? We have P. Here this is connected to Q, so this will be Q complement. These two inputs are passed through where? It is passed through your, just give me a second. So it is passed through where? It is passed through your NAND gate. Here it is Q, and this is again R and Q. It is again passed through your NAND gate. So simply if we solve this, so you need to solve like this. Okay, so here I have used what? I have used De Morgan's rule. De Morgan rule I applied, then I kept on solving this, and I got the simplified form Q complement plus R, which is option C. Very simple question. Okay. So this is the next question. Yes, tell
So,
me. Any
yes, sir. So the third step in simplification, so that q bar plus rq, you just change it to q plus q bar like how?
where this one?
No, sir. After that, and the second step, you change, no? Yes,
This
sir.
one?
After that,
Is this
yes, sir.
your
After
first
that,
class?
no, sir.
So I had explained the distributive property, you forgot.
Sir, I'm asking that second last step, sir.
This one.
Yes, sir.
So this is q complement plus q. So this will be 1.
Yeah, but sir, there is like sir q bar plus r, and you take it like in a single bracket, and there's q, so there you change where the q r q1.
What I am not getting?
So this q bar is then so q complement plus r into q. Okay.
Q complement plus RQ. Yes. So
Yeah. Then sir from q you just let it vanish like where's that q?
where Q I am not getting. So this is what I am doing. A plus BC is what? A plus B, A plus C. So this is the distributive property. So
Oh
that is
yes
what
sir.
I have.
Yes sir. Sorry.
Okay. So now this question solve everyone. Very good question. I am giving you 1 minute to think about this question. Answers anyone? So this is a good question. Okay, very good question.
B,
So look here. What?
option B.
Let us check. So what is given? The output Y in the circuit below is always 1. So this needs to be 1 when? So if this needs to be 1, so that means what? What should be the condition? This is your NAND gate. Okay. So if this needs to be 1, so what can we do? So look at the option. 2 or more of the inputs of PQR are 0. Two or more of the inputs of PQR are 1. Any odd number of inputs PQR is 0. Any odd number of PQR is 1. Okay. So here it is said what? Let us check option wise. Okay. So it is said 2 or more of the inputs PQR are 0. 2 or more. So let me take any 2. So if I take PQ0 and this as 1, so what will I get? So this is 0, 0 into 0, this will be 1. From here again I will get 1. So this will be 1 into 1, so this is 0. Okay. And over here this will be 1, so I am getting 1. Now check over here, this is 0 into 1, so this will be 1. Okay, so this is already done. So I should be checking this one. Yes. So here you can see this is 1 into 0. So this will be 1 and this is 1. Okay, 1 into 1. So this is coming out to be 0. But in the question, it is said that this should be always 1. So option A is incorrect. Now look what is said. Any odd number of PQR is 0. Any odd. So if I have to take odd, so 1 is a odd number, 1 is an odd number. So I am taking just 1 0 and remaining all ones. So if I do that, so what will be this? So this will be 1 and over here this is 1 into 1, so this will be 0. So this is 1, again this is 0. Okay. And if any one of the input of your NAND gate is 0, obviously your output is going to be 1. So any odd number of input, if I take 1 0, it is satisfying. Now let me take 3 zeros at once. Okay, because 3 is also odd number. So if I take 3 zeros at a time, so this will be what? This will be 1, and this will be 1, and over here this will be 1. So if this is 1, so this will be 0. Over here this is 1. 1 into 1, so this is 0. Okay, so again this is false. Any odd number of input PQR is 0. This is also false. So in this over here, any odd number of inputs of PQR is 1. So let me take this. So let me take first all the 3 inputs as 1. So this will be what? This will be 0, this will be 0, this will be 0. This is what? This will be 1. And if this is 0, okay, this is 0. So obviously this is going to be 1, because any one of the input of NAND gate, if it is 0, output will be immediately 1. Okay. So now let us check for a single one if it is satisfying our condition. Okay, because it is said any odd number of inputs of PQR is 1. So this will be what? 1 into 0. So this will be 1. This is what? 0 0. So this will be also 1. This is also 1. So this is 0. This is 1. So this is 1 into 1. So look here. Again this is coming out to be 0. So option D is false. Only remaining is what? Option B. So you can mark option B, or you can even check this like we have done. Okay, like we have done, you can check this also. 2 or more inputs of PQR are 1. So if you do that, see, if 2 or more of the inputs of PQR are 1, obviously you will get 1. So take any 2 inputs as 1. So like if I take this 2 as 1 and this as 0, so what will be this? This will be 0, and even this will be 0, and here this will be 1 into 1. Sorry, these are going to be 1, 1, 1, and this is 0. Okay, so 1 into 1, this will be 0, this is 1, so this is 0, this will come out to be 1. Now if you take 3 ones, we have already checked for 3 ones, it is coming out to be 1. When it is single one, at that time it is coming out to be 0. So once again I am not checking. So option B is your correct answer. So this was a very good question. Okay, very good question. Now this question, this question. So you guys do, I am just checking something. Okay, so what answer are we getting? So here only I will discuss with you. Okay, I will discuss this with you over here. What answers are we getting? Option A. Okay. So look very carefully. Now, it is said what? The Boolean expression. So this is given. This is in your, you can see, standard SOP. Okay, standard SOP converted into canonical product of sum, POS form. Okay, POS form. So now look very carefully. If you want to convert this, there are two ways. Okay, there are two ways to convert. First, either whatever is given, like f, x, y, z, you take complement. Okay, POS SOP means what? SOP means, if you go and check in SOP, more importance is given to 1. Okay, more importance is given to 1, and in POS more importance is given to 0. So we will discuss why is this like this. We will discuss in K-map, but at the moment I am telling that for SOP more importance is on 1 and for POS it is on 0. So either for converting this SOP to POS you take whole complement, or you can do one thing, you just see, means this method I want to discuss now only. So look here, it is given f is equal to what? X complement y z complement plus x y complement z complement plus x y z complement plus x y z. So this over here, it is a 3 variable Boolean expression. Okay, 3 variable Boolean expression. That means you can have from 0 to 7. And I told what? In SOP, more importance is to 1, and in POS, more importance is to 0. So note this down. We are going to discuss why. Okay, or even we can discuss over here also. It's no big deal. So look over here. Suppose I give you a minterm x, y, z. So let me ask you, when will this be 1? When will this be 1? For what combination of x, y, z will this be 1? For what sequence?
So when x, z will be 1 and y will be 0.
So it will be 1, 0, 1. You are telling me. For this unique combination, this will be 1. Now let me ask you, when this will be equal to 0, can you give me a unique such sequence? You cannot give me a unique sequence. Why? If you take something like this will be 0. Even if you take, this will be 0. Or even if you take, this will be still 0. So there is no unique sequence for 0 in your SOP or in minterm. So the uniqueness is where? Uniqueness is in 1. So that is why in SOP our 1 is more important. Now let us come to POS. Now tell me, for what unique combination will this sequence be equal to 0?
Or any combination other than 101.
Think again. Think again, Shubham. Think again. So this will be 0 only when x is 0, y is 1 and z is 0. Okay, for any other combination you take, this will not be 0. Okay, this will not be 0 for any other combination. Now for example, if I want to make this 1, so there can be like, if I take x1, y0, z0, this will be 1. If I take x1, y1, z1, then also it will be 0. If I take x1, y1 and z0, then also this will be 1. So here you can see in POS term, uniqueness is in 0. Okay. So for SOP, uniqueness is in 1 and in POS, uniqueness in 0. So tell me if this is clear or not. So why we usually search for 1 in SOP and why do we search for zeros in POS? This is now hopefully clear to you. If there is any doubt, you can ask. So now look, these are all minterms. Why minterms? Because these are in your SOP form. So what is the minterm number for this one? So this is 0, 1, 0, this is 1, 0, 0, this is 1, 1, 0 and this is 1, 1, 1. So this is what? This is M2, this is M4, this is M6, this is M7. Now in a Boolean expression, okay, in a Boolean expression, if there is no don't care, okay, if there are no don't care, so whatever is your SOP or whatever is your minterm number, the remaining numbers will be max term. Okay, if there are no don't care, so if there are no don't care conditions, I will explain what is don't care, just give me a moment. If there are no don't care conditions, then whatever is your minterm numbers, all the remaining numbers will be your max term. So look over here, this is a Boolean expression using 3 variable. So with 3 variable, we can go from 0 to 7. So out of those 2, 4, 6, 7 is your SOP. So the remaining are your max term, as there is no, means there is no say, means there is nothing said about don't care. So that is why the remaining terms are max term. So obviously 0, 1, 3, 5 is your what? It is your max term. So how do we write 0 in your POS form? So POS form, this will be 0, 0, 0 or 0, 0, 0 corresponds to x plus y plus z. Okay. Sorry, 0, 0, 0. So this is x plus y plus z. 1 will be what? 0, 0, 1. So 0, 0, 1 will be x. Means am I making some mistake? No, it's okay. So x plus, see, I will write it down. So this is what? This is your 0, 0, 0. This is 0, 0, 1. This is 0, 1, 1. And this is 1, 0, 1. And I told you what? In POS, 0 corresponds to normal and 1 corresponds to complemented form. Okay, so 0, 0, 0 will be what? X plus y plus z. This will be x plus y plus z complement. This will be what? X plus y complement plus z complement, and the last one will be x complement plus y plus z complement. So which option do we see? So check x plus y plus z, x plus y plus z complement, x plus y complement z complement, x complement plus y plus z. So option A. Option A is your correct answer. Very good, Shruti. Okay. So option A is your correct option. So if you have any doubts, you can ask, or else I will be explaining you one more concept, that what is don't care. Okay. So all of you might have heard about binary coded digit, BCD. Okay, binary coded digit, where we represent decimal number 0 to 9 in 4-bit binary string. Okay, 4-bit binary string. We define our from 0 to 9 decimal number. Like suppose if I want to write 21, so how will I write in BCD? 1 corresponds to 0001 and 2 corresponds to 0010. So the BCD string for 21 will be 0010 0001, like this. Okay. So basically what we are doing, we are going from 0 to 9. Now listen very carefully. What is don't care, I will explain. So in 8421, this is your MSB, this is your LSB. So MSB has weight 8 and LSB has weight 1. So 0000, this corresponds to decimal 1. This corresponds to decimal 0. This corresponds to decimal 1. This to 2, this to 3, 4, 5, 6, 7, 8, 9. But what we know, using 4 binary digits, okay, using 4 binary bit, what we can do, we can represent number from 0 to 15. So in 11, means in BCD, 11 is represented as 001 0001. Okay, in BCD this is represented like this. But in 4-bit binary, 11 is represented as what? 1011. Okay, sorry, this is 10. So 1011, that will be your 11. So 9, I should have written 10 over here. This is 10. And after this, it will be 1011. So this will be 11. Even 10, this is invalid BCD. So how do we represent this invalid BCD? We represent it with don't care. So don't cares are those conditions in your Boolean expressions which do not occur. Okay, it does not occur. Did we understand the concept of don't care? So in any question, if there is no mentioning of don't care, then this will hold true always. Whatever is the min term number, all the remainings are going to be max term number. But if there is mentioning of don't care, it will be mentioned in the question explicitly that these min term, these numbers, these are what? These are your don't care. So if any doubts, let me know, or else note down this concept. We will move on to the next question.
Um,
Any
so I,
doubts?
so I didn't get that don't care thing.
See, don't care means what? Don't cares are those conditions which do not occur. Like in BCD, I told you 10 is an invalid number. 10 is invalid. Why? Because 10 in BCD it is represented as 0000 and this will be 0001. So this is the BCD representation of 10. Because in 10 any number is represented with its 4-bit equivalent binary number. Okay, here you can see with 4 bits we can denote 10 like what? 1010. So this is invalid in your BCD case, so that is why I am putting a don't care or a cross over here. Don't care are all those cases in your Boolean expression which does not occur. Now did you understand?
Yes.
Okay, so now note down this concept. Next question, tell me. So here sum of product is asked. Just the opposite. If nothing is mentioned, that means there is no don't care. See, if you don't understand any concept, you are free to ask, okay? Once, twice, even thrice. It's okay. I will explain you. But don't sit quietly. See, here these are written in your POS form. So this corresponds to the maximum number. See, normal number over here is 0 and complemented form is 1. So this will be 0, 0, 1. This will be what? 0, 1, 1. This will be what? This will be 1, 0, 0. And this is what? 1, 1, 1. So this corresponds to 1, this corresponds to 3, this corresponds to 4, this corresponds to 7. So this is a 3 variable Boolean expression. So we can go from 0 to 7. Remaining all numbers are your minterm numbers. So that is 0, 2, 0, 1 is taken, 2, 3, 4, 5 and 6. So 0 will be what? It will be 0, 0, 0. So that will be, sorry, A, B, C. Yeah. So A complement, B complement, C complement plus A complement, B, C complement plus 5 will be what? 1, 0, 1. So that will be A, B complement, C and 6 will be A, B, C complement. So which option do we see? Option B. Okay, option B. Are we understanding the concept? Is this clear, everyone?
Yes,
Tell
sir.
me yes or no.
Yes, sir.
Everyone. For yes and no, Shubham, you can type in the chat box, okay? If you guys have doubt, you can unmute and speak. But for yes, no, you can just type in the chat box. And no need to write yes, sir, okay? It consumes a lot of time. Simply write Y or N. No salutations are required, okay? No, sir, nothing. It's okay. Okay. So now this question, this is your midterm expansion of this one. So very quickly, tell me what will be the midterm expression? So you might be thinking that these questions are irrelevant or what we are doing, okay? But I am sharing you few tricks over here that will be helpful when we go ahead. So solve this question very quickly. See, for getting the midterm, you require the standard SOP, or for even getting max term number, you require standard SOP. But here you can see the midterm given is not in its standard form. Any answers? So look over here. So if I convert this SOP to standard SOP, so here it is PQR. So here R is missing, so I can write it like PQ R plus R complement. Here P is missing, so this will be P plus P complement Q R complement. Here Q is missing, so this will be P Q plus Q complement R complement. So if I expand this, this will be PQR plus PQR complement plus PQR complement plus P complement QR complement plus PQR complement plus PQ complement R complement. So this corresponds to 111. So this will be 7. This corresponds to 110. So this will be 6. This corresponds to 110. So again this will be 6. This corresponds to 0, 1, 0. So this will be what? 2. This corresponds to 110. So this will be again 6. This corresponds to 100. So this will be 4. So your midterm numbers, if I write in ascending order, so that will be M2. So 6 is occurring thrice. Only once I will write. So okay, before that 4 is also here. So M4 plus M6 plus M7. So which option do we see? 2, 4, 6, 7. Option A. Okay. Option A is your correct answer. Now this is quite lengthy method. You can see that I took like 3-4 minutes to solve this. Now how do we solve such question during exam? So look, this is a lengthy method that I did. See, in exam, nobody, I have written a comma over here, so this is plus. Look, in exam we don't do like this. So this is the order of variable, whatever is given. So P is MSB, R is LSB. So you need to maintain this order. Okay, this P is MSB, R is LSB. Even if it is not said, it is given in this bracket. You can see P is written first, R is written last. So P is MSB, P is MSB, R is LSB. So now if this is the case, what can you see? R is missing over here. P and Q is given. P is in non-complemented form, even Q is non-complemented form. So P is 1, Q is 1. What is missing? R is missing. So for R, I put a cross over here. So this means what? Either R will take 0 or it will take 1. So immediately if this thing comes, so if this is 0, so if for 0 this will be 5, if this is 1, this will be 7. So over here you can see P is missing, Q and R both have value. So Q is what? Q is 1, R complement, so complement in SOP form corresponds to 0. So P is missing, so for P I put a cross. So this cross corresponds to either 0 or 1. So if I take 0, this will be 2. If I take it as 1, this will be 6. For this one, here you can see Q is missing. So P has value 1, Q is missing, so I will put a cross in its place, R is 0. So in place of this cross, first put 0. So this will be what? This will be your 4. If I put 1, so this will be 6. Now you have your midterm numbers. You can see that is your M2, M4, M6. So why am I getting 5 over here? P, Q, okay, sorry. So this over here I have done a mistake. R was missing and I have taken Q as missing. So P has value 1, Q has value 1 and R it is missing. So this will be don't care. So for this if I take 0, so this will be 6. If I take 1, this will be 7. Now it is correct. So if I write the midterm number, so this will be M2 plus M4 plus M6 plus M7. So did we understand this method? If any doubts, let me know. So this is a far simpler method to solve. Okay, very simple method to solve. Like if I ask you one question. So I have one more question based on this. So this one. Very quickly tell me what will be the expression you get after minimizing. See, this hyphen means it is complement. We write it like this or we can even write it like this. Okay, a complement or a hyphen, whatever you want to write, a dash. So for this question, what is your answer? Let me know. So I told you what, if your expression is given in SOP, if I take complement, whole complement, so this will give me POS. Okay, POS. So now solve this. Okay, now solve this. Did we understand the concept or not? So solve very quickly. See, basically they are asking minterms after minimizing the following expression. Okay, what will be the minterms that remains after minimizing the following expression? Okay, or else let us do one thing. Let us solve this question after understanding K-maps. Okay, first let us see what is K-map. So any answers did we get? So we can even solve it over here. It's okay. So look very carefully. Let me solve this for you. So it is given what? B complement plus AB complement, or I will just write it in the form which I am comfortable, plus A complement C plus AC complement D plus A complement C complement D complement, and on top of that we have a complement. Okay, so at the moment leave this complement. Okay, this is written in SOP form. Okay, so first let me find the minterm numbers for this. So if nothing is mentioned and here it is ABCD, so A will be MSB and D will be LSB. Remember this. So over here you can see this is D complement. So out of A, B, C, D, only D is fixed and it is 0. Remaining A, B, C, we don't know what will be the values. So here you can see this will be what? This will be from 0000 to 00, this will be, next term will be what? 0010. Next term will be 00100. Next will be 010. Next will be this. Then this will be what? 1010. Next will be 1100, and the last one will be 1110. Okay, so this is what? This is 0, this is 2, next will be 4, 6, 8, 10, 12, 14. So I wanted K-map because this would have been simpler. Okay, this would have been simpler if we had used K-map. Now next you can see what? This is A, B complement. C and D are missing. Value for A is 1, for B is 0. This is missing. So this will be what? 1, 0. This should now go on in your mind that when you put 0, 0, this will be 8. If you put 0, 1, this will be 9. If you put 1, 0, this will be 12. And if you put 1, 0, 1, 1, this will be 13. This should now go on in your mind. Okay. So this will be 8, 9, 12, 13. For this one, this is what? This is A complement C. So that means 0, 1. So this will be what? If you put 0, so this will be 2. If you put 0, 1, so that will be 3. If you put 1, 0, so it will be 6. If you put 1, 1, so it will be 7. So this will be what? 2, 3, 6, 7. Okay, 2, 3, 6, 7. Now what? This is ACD. So A, C complement D. So value of A is fixed, B we don't know, C is in your complement form, so that is 0, and D is 1. So obviously if you put 0, so this will be 9. If you put 1 over here, so that will be 13. And for this one, it is what? A complement, C complement, D. So if you see over here, so this is 0, 0. So this will be either 4 or this will be 0. So 0, 4. Tell me up to this point, is it clear? Now I am explaining, so that is why it is taking time. And if we had known your K map, this would have been like a question of 1 minute to 2 minutes. Okay, not more than that. Because I am explaining, so that is why I am taking time. So now very quickly write the minterm numbers. Okay, minterm numbers you write. So I am erasing all this part, extra additional part, I am just keeping this. So you can see it is 0, 1 is present anywhere? No, 1 is not present. So 0, 2, 3, 3, yes, it is present. 4 is present. 5, is it present any place? So 5 is not present any place. Okay, it's okay. 6 is present. 7 is present. 8 is present. 9 is present. 10 is also present. 11 is not present. 12 is present. 13 is present. 14 is present. 15, no, 15 is also not present. So now what I have a complement over here. So if I complement this SOP converts to POS form. Okay, it converts to POS form. Somewhere I think I have made some mistake. Okay, there should be only one min term for this. Piyush is correct, but I am getting few more over here. Okay, so this SOP will convert to POS. So now these are your POS. So obviously if these are your POS, remaining will be SOP. So remaining is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1 and 15 are present. So this is wrong. So this is wrong. 1 should be present somewhere. So here it will not be present. Here this is 1, 0. No, over here it will not be present.
So the last term is A complement, C complement, and D.
Okay, so this is D. Yes, I have put D complement over here. I am very sorry. So this will be what? So this is A complement is 0, B we don't know, C is 0, D is 1. So if I put 0, so this will be 1. If I put 1, this will be 5. So 5 is already present and 1 will come over here. Okay, 1 will come over here. So now when I do complement of SOP, all these terms now converts to POS. Now these are your POS number after I complement. So the remaining out of this remaining from 0 to 15, which number is remaining? Only 15 is remaining. So 15 is your SOP and they have asked you what? The number of minterms after minimizing. So the minterm number is what? It is 15. If any one of you have any doubt, please let me know. Or else this question will be very, very lengthy if you solve it from normal method. Okay. So always remember, if you have been given with SOP, if you take complement, so then that SOP becomes POS. Or if you have some minterm numbers, if you complement, it becomes max term numbers and vice versa. Okay, vice versa. So remember this concept. This is very, very good concept for solving questions. So we will again come back to this question when we solve K map. Then it will be more simple to see. Tell me if any doubts over here. Any doubts? Okay, fine. So now let us go to K-map. But before going to K-map, let me ask you, what is gray code? What is gray code? It is a kind of reflective code. Okay, reflective code. Now, what do we mean by that? Okay, so before that, let me show you how to convert a binary string to a gray code string. So suppose if I have a binary number 101011 and I want to convert it to gray. So look very carefully what I do. The MSB bit is copied in your gray and the subsequent consecutive bits are XORed. Okay, so 1 XOR with 0, it will be 1. 0 XOR with 1, again this will be 1. 1 XOR with 0, this will be again 1. 0 XOR with 1, this will be again 1. And 1 XOR with 1, this will be 0. So this is the gray code equivalent of the binary string that has been given. Okay, that has been given. So let me ask you a very simple question. What will be the gray code equivalent of this binary string? Write very quickly till that time. So what will be the gray code equivalent of this? So look very carefully. MSB bit I have to copy in your gray also. So this will be 1. Next consecutive bit, just XOR them. So 1 XOR 0, so that will be 1. 0 XOR 1, again that will be 1. 1 XOR with 1, that will be 0. 1 XOR with 1, again this will be 0. So this is the binary equivalent, the gray equivalent of the given binary string. Is this clear, everyone? Any doubts in this? Okay. Chandana, you have some doubt? Okay, fine. So now look very carefully. I have written binary equivalent of decimal number from 0 to 7. Now let me write the equivalent gray code also. So this will be 0 0 0. This will be what? 0. So 0 will come over here, 0 XOR 0. So this will be 0 0 XOR 1. That will be 1. Over here this will be 0 1 1. Next will be 0 1 0. This will be what? 1 1 0. This will be what? 1 1 1. This will be what? 1 0 1, and this will be 1 0 0. Okay, now look very carefully. When we go from 0 to 1 in binary, only the LSB position is changing. Okay, LSB position is changing. So there is a bit change in only one place. But when we go from 1 to 2, you can see MSB is remaining the same, but this middle term, it is changing from 0 to 1 and LSB is changing from 1 to 0. So there is a bit change of 2 over here. Okay, 2 bits have changed. But now look at gray. For gray, if you see, so when you go from 0 to 1, there is only 1 bit change in the LSB. Now if you go from 1 to 2, okay, 1 to 2 if you go, LSB is remaining the same, MSB is remaining the same, only this middle bit is changing from 0 to 1. Now similarly, if you go from 3 to 4, so if you go from 3 to 4 in binary, you can see all the 3 bits are changing. MSB is changing from 0 to 1, This middle term is changing from 1 to 0 and this LSB is changing from 1 to 0. But now go to the gray equivalent. If you see, look over here, only this MSB is changing from 0 to 1, rest remaining bits are not changing. So remember this, in gray code, basically only one of the subsequent bit changes in your consecutive numbers. Okay, only one of the subsequent bits will change in your consecutive number in gray code. So that is why if I just do what? If I rotate this, okay, if I rotate this and bring it over here, okay, suppose if this is this number, look very carefully. If all this gray code, okay, if I write this gray code on a piece of rectangular paper like this, okay, if I write it on a piece of rectangular paper, and now what I do, I simply take this edge over here and make a cylinder like this. Okay, if I make a cylinder like this, so you can see what, this end will be connected to this end, and again you can see in between these two there is only what, there is a bit change of one position. You can see only in this MSB part, this is converting from 0 to 1, remaining all are 0, 0, 0. So this is what is meant by reflective codes. Okay, so there is only one bit change and there is a size, means what if I just do what, means it is very hard to explain. So that is why I have drawn this, that if I form a solid structure using this codes, it is basically what, there is only one subsequent bit change in your consecutive numbers. Is that clear, the concept of gray code? Any doubts in this? You can ask. If you have any other queries also, you can ask about gray code. Okay, so now let me explain how to convert gray to binary also over here. Okay, because later on we are going to see. So suppose if you have a gray code, okay, gray code to binary. So let me take the previous example only, this one. Suppose I have a gray string, okay, gray code string I have. So how do I convert it to binary? So again it is the same thing. This is gray code, I need to convert it to binary. So simply what we are going to do, copy the MSB and then this result needs to be XORed with the next input gray code. So 1 XOR with 1, this will come out to be 0. This 0 will be XORed with the next one. So 0 XOR 1, this will be 1. If this one has to be XORed with the next bit, so 1 XOR 1, again this will be 0. This 0 will be XORed with this one. So this will be what? This will be 1. And again 1 XOR with 0. So this is 1. So this is your binary equivalent. If you go and check, this is what I had taken in the first place for our example. So for gray code to binary, we need to basically XOR the input bit with the next consecutive bit of your gray code. Okay, so this is how we convert gray code to binary. Now let us go to K-map. So K-map is basically a kind of map which is used to simplify Boolean expression. So K-map uses gray code. Okay, we use gray code over here. So this is basically a two variable K-map. Okay, two variable K-map where we have functions of A and B. Let me assume I am taking SOP over here. So let me assume I have a function of A to B where there are minterms numbers like M 0 1. Okay, 0 1. So 0 means what? This is your minterm number. Okay, minterm number. So 0 means what? 0 0. 1 means what? 0 1, because this is your 3 variable. So sorry, 2 variable. So AB can take values from 0 0, 0 1, 1 0 to 1 1. Out of this two are what? This two I have assumed that it is your minterms. So how will I put over here? So this corresponds to B, this over here corresponds to B, and this corresponds to A. So I will write all the combinations of AB. So this will be B, this will be, sorry, this will be B complement, this will be B, this will be A complement, this will be A. So A complement means what? In your SOP form, remember, in your SOP form, complement means 0, non-complement means 1. So similarly, over here also, this will correspond to 0, this will correspond to 1. So this whole cell, this is the cell, okay? This cell will correspond to, look over here, what is the value of A? Value of A is 0, value of B is also 0. So 0 0, so basically this will correspond to your minterm number 0. Over here A is 0, B is 1, so this will be 1. Over here in this cell A is 1, B is 0, so this will be 1 0 means 2, and this will be 3. Now look over here, where do we have the minterms? We have minterms at 0th cell and first cell. Now for minimizing this expression, we know what? If we have such kind of minterms, this means what? Don't copy now, okay? For copying, I will give you some time after this slide, okay? So at the moment, just listen what I am saying. So this I could have written like A complement B complement plus A complement B. So if I simplify this, this will be A complement common, B plus B complement, and this will come out to be A complement. Okay, so we know we could have solved like this and got the minimized expression. But now I want to minimize this expression using your K-map. So how will I do? I will start making group of ones. Okay, for SOP, we make group of ones, okay, and the size of the groups, it will be to the power of 2, either 2 to the power 0, 2 to the power 1, 2 to the power 2 till 2 to the power n. So size of means the grouping size can be either it will be 1 or 2 or 4 or it will be 8. So we will see one by one how to make such groups. And remember one thing, your groups will be either horizontal or vertical. Okay, groups will be either horizontal or vertical. It cannot be a slant group, means something like this. You cannot have a group of ones like this. This is invalid. Either you will have groups like this. So this is what? This is your horizontal group of 2, or you can have a group like this. So this is your horizontal, vertical group of 2. If you had one more one over here, so you could have made 2 groups. See, you cannot make a group like this. Why? Because this is an invalid group. You cannot make a group of 3. Your group, it should be in the power of 2. So one group will be like this, one horizontal group, and another vertical group of 2. This will be like this for this particular case. So for our example, look very carefully. We have 2 ones like this. So I can make a horizontal group. Okay, I can make a horizontal group. Now how do I write the minimized expression? This is the most important thing. So in this 2 group, what is common you can see? So if you go and check for B, over here in this cell B is 0, in this cell B is 1. So this is not common. But if you go and check for A complement is common for this cell as well as this cell. So I am going to write A complement over here. As this is your SOP, so we are going to write this in minterm. So at the moment this is 2 variable K-map, so it is quite simple to write. Okay, is this clear? Tell me up to this point. Is this clear? If it is clear, very quickly note down whatever I have said. Note down very quickly. Then I will be moving on to the next concept. So quickly, I am giving you 1 minute to note down. Noted? Okay. So now look, I made SOP. So I told you what? If there is no mentioning of don't care, whatever is your minterm numbers, the remaining numbers will be SOP. So this is what? This is your B complement. This is B. This is A complement. This is A. So now I am going to write in POS form. Now this is very important. In POS form, look very carefully. Complement corresponds to 1. Okay. Complement corresponds to 1, or you can leave it like this. It's okay. I will not confuse you. See, these cells are going to be 0, 1, 2, 3. Don't change this. Okay. Don't change this. Now, look very carefully. So this is 0. You just follow one style. I will not confuse. You just follow this style. Now in POS, the remaining places will be what? It will be filled with 0. So simply what I am going to do? I am going to make a group of 0 now. Okay. In in POS, we make group of zeros. This rules all remains the same. Size of the group should be like in the power of 2's. Group should be horizontal and vertical. No means slanted groups is not valid. Okay. Rest all the conditions remains the same. Okay. Everything. When you make the K-map, just follow this logic only. Okay. Just follow this logic. Now, when you write the simplified expression, at that time, just keep in mind that when you write, see here, so over here if you check, B means this cell, if you go like this in your horizontal fashion, so you can see what? Over here it is B complement, here it is B. So in B nothing is common, but if you go and check, A equal to 1 is common. A equal to 1 is common. And I have told you clearly that 1 corresponds to what? 1 corresponds to non-complemented form in your POS. Okay. 1 corresponds to non-complemented form in POS. So this I will write as A complement. See, I have written A complement. Now if you check, basically this is what? This is the same Boolean expression I have done. Okay. Same Boolean expression. So my result should also be the same. It is just a different way of representation, like Rahul Day, it is my name. Okay. If anyone asks you who is Rahul Day, you will say that he is your digital teacher. But if someone asks you who is Day Rahul, it will also imply me only. Okay. It will imply me only. It is not like that this will be some other guy. It is just a different way of representation. I might be also identified with my Aadhaar number. Okay. So it is just a different way of representation. It doesn't mean that I am changing. If someone goes and tell you my Aadhaar number, so if that number is mine, it will what? It will direct you to me and I am the same person. So basically SOP and POS, it is just a different kind of representation for the same Boolean function. So this you can see, this is very important. In SOP, always remember 0 corresponds to complement and 1 corresponds to non-complement, and in POS 0 corresponds to normal or non-complement and 1 corresponds to complement. Okay, tell me if up to this point whatever I told you, is this clear? If it is clear, then we will go to 3 variable K-map. Now your real concept will start if you don't know about K-maps. Okay, so copy this down very quickly. Okay, so now let us move to 3 variable K-maps. Okay, what is 3 variable K-map? Again, I am taking one example. F is equal to, where f is function of a, b, c, and I am taking minterms as 0, 1, 2, 6 and 7. Okay, I am taking this minterms. How many are remaining? So 1, 2, 3, 4, 5. Okay, fine, I can show you. Or let me just cancel 1. This is okay. So now I am not going to write a complement a. I am not going to write. Simply I will be writing 0, 1 over here, and over here 0, 0, 0, 1. See, in your gray code, basically after 0, 0, 0, 1, 1, 1 will come, and after that 1, 0. You can find out yourself 0, 0, 0, 1, 1, 0, 1, 1. This is your binary equivalent. Okay, for 0, 1, 2, 3 or your decimal. Now if you calculate gray, this will be 0, 0, this will be 0, 1, this will be 1, 1 and this will be 1, 0. So that is why I am taking, look over here, I have taken gray code. Basically this representation is in gray. Okay, this representation is in gray numbers. Now look very carefully. Look very carefully. So this cell will correspond to 0, 0, 0. This cell will correspond to 0, 0, 1. This cell will correspond to 0, 1, 1. This cell will be 0, 1, 0. This will be what? 1, 0, 0. This will be 1, 0, 1. This will be 1, 1, 1 and this will be 1, 1, 0. So 0, 0, 0 means what? It will correspond to 0. This 0 only, because I am writing POS over here. So this I am representing I am representing the SOP. SOP means what? Minterms. So if these are your minterms, what will be your max term? So max term is denoted like this. Okay, pi, capital M. So all the remaining numbers will be max term. So that will be what? 0, 1, 2. So 3, 4, 5. These are your max terms. Even 7 also. Okay, so these will be your max terms. So now I am going to write simultaneously. Okay. See, I am repeatedly telling, for filling the numbers, don't change this. So this will correspond to 0, this will be 1, 3, this will be 2, this will be what? This will be your 4, 5, 7, 6. Just the binary equivalent, sorry, decimal equivalent of this binary numbers I have written. Okay. So you can see 0, 0, 0 corresponds to 0, 0, 0, 1 corresponds to 1. That is what I have written. Now look, okay, very carefully look. So this is 0, this is 1, this place is 2 and 6. So where is 6? Here it is 6.
So it will be 1 now.
Yes, yes, yes. Okay, this will be 1. Now all the remaining places I will fill with 0. So this place will be 0, 0, 0 and this will be also 0. Now let us start making the groups. Okay, so you can see over here that you can make groups like this. Either you can make a group like this or like this. So first I am showing you the grouping means how can you group. Okay, so you can make group like this, or even you could have made group like this. This is one group. Okay, this is one group. This can be your another group and this can be another group. But if I want to get the minimized expression, so listen very carefully, note this down afterwards. If I want to get minimized expression, number of groups either of 0 or 1, it should be minimum. See, basically I told you what when I was doing over here, this term and this term, if I connect them, these are consecutive terms. Similarly over here, this if I roll on a piece of paper and connect it over here, so this and this, they are consecutive numbers. So even I can group like this one and this one, I can group it like this. But when I group like this, I am getting 3 group of 2's. Okay, 3 group of 2's, which is not necessary because I want to minimize this expression. So what I am going to do, I am going to make a group of 1 like this and 1 like this. Now look how I am going to write the SOP expression. Look very, very carefully. So this will constitute one of the minimized expression or one of the minimized SOP term, and this will give to another minimized SOP. So look how will I write this. So this I will write in SOP form. So if you check, A means 0 corresponds to A bar and this corresponds to A. So 0 means complemented, 1 means non-complemented. So write this, 0 means non-complemented and 1 means complemented. So now see. So over here 0 is common for A, so I will be writing A complement. Now in this horizontal row, okay, in this row, what do you see? What is common? So over here value of B is 0, over here also value of B is 0, here C is 0, C is 1, so B is common, B equal to 0 is common, so along with this I will write B complement. So the minimized SOP for this group is A complement, B complement. For this one if I want to write, so this is your sum terms, sorry, product terms, sum of product. So I will be basically doing sum of the product terms. So the next product term will come from here. So if you check over here, A is not common because here A is 0, here A is 1. But this B equal to 1 and C equal to 0 is common over here. So I will be writing B, C complement. So this is the complete SOP for this expression. Now if I want to write POS, so look very carefully how I write. So 0 corresponds to normal number, means normal variable, and 1 corresponds to complement. Okay, 1 corresponds to complement. Now let me make the groups. So I can make group like this. This is one group. Another group I can make like this. Then there will be one more group like this. But if I want to get the minimized POS expression, my number of groups should be minimum. So you can see this group, it is redundant group. because all other zeros have been covered when I make group like this. Okay, no more zeros are present over here which is not covered by a group. Okay, so this is what, this is your best possible grouping that I can do. So now look, how do I write this expression for POS for this? So 0 corresponds to normal, 1 corresponds to complement. So in this you can see A equal to 1 is common, so write A complement, and from B and C what is common? B equal to 0 is complement. So this is what, this is POS, product of sum. So I will be writing the sum terms. Some terms will come from the group and individually I will be doing product. Okay. So the first sum term will come from this group. So this group corresponds to what? A plus, over here you can see what is common. So B equal to 0 is common. So this will be A plus B. Now what about this? If you check, A is not common, B equal to 1, C equal to 1. So this will be B complement plus C complement. So right over here, B complement plus C complement. Okay. So now you got the SOP and POS. Now you might be thinking, sir, you told us that SOP and POS basically they both are same. Yes, obviously it is same. Now look very carefully. If I have this, this is what? This is the POS expression. So look very carefully. I will give you time to note. Don't worry. So if I expand this, this will be what? A complement B complement plus A complement C complement. This will be B complement into B. So this will be 0 plus BC complement. Okay, BC complement. Now if I solve this, okay, if I solve this, this is what? AB complement plus AC complement plus BC complement. This is in which form? This is in your SOP form. Now if I calculate the min terms for this, so what you can see, A equal to 0, B equal to 0, C is not present. So this will be 0, 1. For this term, A equal to 0, B is not present, C equal to 0. So this will be also 0, 2. For this one, A is not present, B is 1, C is 0. So this will be what? This will be 2 and this will be 6. If I write the min terms, that is 0, 1, 2, 6. So 0, 1, 2, 6 is what? From this is the place only we have started. You can see from this POS expression, I got this SOP expression which is same as the example. Now did we understand what I was trying to say to you? Did we understand or not? If it is clear, quickly make your notes. Then I will give you one more example. Quickly note it down. And means I am forgetting every day to actually give you the slides. Okay. So today, right now after class, I will make this Google Drive and I will share the class notes with you. So very quickly note it down. Is it noted? Yeah, quickly note. Yes. So now let me give you one example. Okay, we can solve this later. So here you are going to write SOP. Here you are going to write POS very quickly. I will be back in like 1 minute. Okay. Answers, anyone? So look, if I make groups, okay, group of one, so I can make one group like this. See, your first aim should be to maximize the group size. First aim, maximize group size. Okay. Second should be minimize number of groups. Okay. Minimize number of groups. So maximize group size, here I can make either group of 1, group of 2, group of 4. So 4 is not possible anywhere. I have to make group of 2. So this can be 1, another can be this, and the third will be this. So now if I start writing, so first write all this. So if I make for this group, this is my group 1. So this is what? A complement. Now look common in B and C. So that is what? C equal to 0. Next will be what? Next, if I am writing for this one, so A equal to, sorry, so over here this should be 1. A equal to 1 is common in both, so that is A. And out of B and C, what is common? C equal to 1 is common, so A plus C. Next, if you write for this one, so A is not common, B equal to 1, C equal to 0 is common, so this will be BC complement. So this is what? This is your SOP for this expression. Now if you want to write POS for this expression, so look very carefully how I make the groups. So can I make, means first look, I can make a group of 2 like this. One more I can make like this. And one more I can make like this. Tell me, is this correct? Is this correct? Is this okay? This is not, means this is correct. Okay, this is correct. Grouping is correct. But you won't be getting minimized Boolean expression or minimized POS form. Why? Because my main aim is what? Maximize group size and minimize number of groups. And I have violated one of the things. What? I haven't maximized the group size. See, I could have made a group of 4 like this. Okay. So this is one group of 4 and this is one more group. So if I have to write POS, okay, if I have to write POS expression, so look very carefully in this small group of 2, what is common? So A equal to 0 is common. So this is in POS form. So 0 corresponds to non-complement. Out of B and C, B equal to 1 is common. So first sum term is over. Now the next sum term. So you can see what? This group of 4. So in this group of 4, you can see A is not common because A is equal to 0, A is equal to 1. You now need to see in all the 4 cells what is common. In all the 4 cells. So A is not common in all the 4 cells. B equal to 0 is also not common. But C equal to 0 is common in all the 4 cells. So this will be C. Okay. So how many of you got both of the answers correct? How many of you got? Okay, very good, Shubham. So now the last example. Okay, last example. Why others couldn't get the answer? Why? Tell me the reason. Tell me the reason why we couldn't get answer. Where is the problem? Chandana, Shruti, Piyush. What happened? I got AC plus AB. Why AB? Plus A complement C complement. From where did you get AB? It's okay. Let me know for this one. Violated second condition in POS. So that is wrong. So it's okay. You will learn. So K map you get with practice. Okay. The more you practice, the more you get correct answers. So over here you can see now. So I cannot make any groups. Okay. I cannot make a group of two like this. This is invalid grouping. Okay. Because I told you the structure of the group, either it should be horizontal or it should be vertical. This is slanted group. So I will be making 4 groups of 1 like this. Now if I write the SOP expression for this, so this will be A complement, B complement, C complement plus A, B complement, C plus A complement, A complement, B, C plus A, B, C complement. And if you now solve A XOR B XOR C, you will get this only. So this will be your homework to check whether you get A complement, B complement, C as this expression or not. Okay. Now let us come to 4 variable K map. So in 4 variable K map, look very carefully. I have examples or not? Yes, I have examples. So look. So how am I going to make combinations of AB? So if I fill this, this will be 0, 1, 2, 3, 4, 5, 6, 7. Here it will be 8, 9, 10, 11, 12, 13, 15, 14. Okay. So this will be all your cell number. Same over here also. Same over here. Now, let me give you and ask you first, what will you do? So let me take first SOP. So group of ones, let me so this is okay. Solve and tell me. So this is not equivalent, okay? I have taken two different SOP and POS because you can see all the places which are vacant, it is not filled with 0, okay? So this is a different expression. Now we have learned that concept. So how many times I am going to repeat? That SOP and POS for a same Boolean expression, it is the same thing, okay? So tell me what will be the SOP for this K map 4 variable and for this one. Bhumika, any doubt? In case of any doubts, no need for typing. You can just unmute and speak to me. Okay? And there is nothing to be afraid of. There is nothing to be afraid of. See, okay, SOP is equal to A complement D complement A complement B plus AB complement D. Okay. So if you are getting the same thing, Bhumika, you can write same. It's okay. Your voice is. Am I audible properly to others? Shubham, you want to say something? Yes. You rejoin once again. Okay. So I will solve this. I will solve this one. Look. And if it is not clear, Bhumika, I will say. Okay. She went offline. So look. I will make one group. Now you can see that I can make one group of 4 like this. Okay, I can make one group of 4 like this and another group of 4 like this. So this is a group of 4. Okay, this is a group of 4. Now you can see. Now this is a group of 2 and this one is one more group of 2. So tell me, how many of you got this? How many of you got this? Anyone? Shubham raised hand. Okay.
So,
Yes.
so why not let all 4 of them, that 5, 7 you took now, why not 4, 5, 6, 7?
Yes, I will explain. I know. Since you are telling me, it's okay. I know. So if I tell you the answers, we learn better from our mistakes. Okay? We learn from our mistakes always. So I wanted to show you the wrong thing. So if none of you have got, so this is a common mistake. See, my first and foremost condition was what? Maximize group size and minimize number of groups. So here I have violated one thing. If you see this one, this group, I could have done what? I could have grouped it like this. Then my number of groups, it is still 3. Previously, when I was doing a group like this, at that time also number of groups were 3. But when I do like this, still my number of groups are 3. But the group size for this group has increased from 2 to 4. So now I will get what? I will get your minimized expression. So for this group, what will I get? So out of AB, what is common? A equal to 0 is common. So A complement. Out of CD, what is common? D equal to 0 is common. So A complement, D complement plus this group, what is common? So you can see only A equal to 0, B equal to 1 is common. So that will be A complement B plus this group. So what you can do? You can see there here out of A, B, C, D, AB is common. So that will be what? A, B complement. Out of CD, what is common? So C equal to 0 and D equal to 1. So D equal to 1 is common. So this is your SOP form. So I guess A complement, D complement, A complement B, AB complement D. Yes, Shruti got the correct answer. Others might have also got the correct answer. Now look for this POS. See, what can I do? I can make a group of 2, something like this. This will be one group. This will be one group. Okay. Group 1. This is your group 2. This is your group 3. And this one is your group 4. Okay, group 4. How many of you got this? How many of you got this? It's okay. Shubham Kumar raised hand. It's okay, Shubham, I will explain. Okay, if you have got this, it's wrong. Means it's not wrong, but you won't be getting the minimized expression. Okay, you won't be getting the minimized expression. Why? Because see, corner zeros, yes, 4 corner zeros are grouped together. So when I connect this point with this point, what happens that this 4 zeros, they are consecutive to each other. They are consecutive to each other. 0 to 8, 10. Either you can join this point to this point, or you can join this point to this point. What will happen? These will become consecutive group, means consecutive zeros. Now this will be group 1, group of 4. Next will be this group, and third will be this group. So if I write for group of 4, so out of A, B, C, D, what is common? You can see A equal to 0, A equal to 1, so it is not common. B equal to 0, B equal to 0 common. So B, out of C, D, what is common? D equal to 0, so this will be BD. Over here, this AB complement means A and B, it is common over here, and both of them have value 1. So this will be A complement, B complement, and out of CD what is common? D equal to 1 is common. So D complement, and for this one you can see B equal to 1 is common. So B complement, and out of CD both of them are common. So this will be C complement, D complement.
Sir,
So
they are
this,
product of sums.
what they are?
The product of sums, sir.
Oh, I am very sorry. Yes, obviously means what am I doing? Very good. So they are product of sum. Yes, you should have told earlier. Means it's okay. I was writing POS, but in your SOP form I was writing. So you can see what is common in this group 1. So B equal to 0 is common. So B, and out of CD what is common? D equal to 0. So B plus D. In this group, A complement plus B complement and D equal to 1. And here it is what? B complement plus C complement plus D complement. Okay, so this is your reduced POS form or your minimized POS form. Yes, it is POS. I am very sorry. Okay, so it's okay. Now let us solve few questions. So this is the first question. See, always I take random questions. After teaching a topic, I don't take question of that topic directly, because in examination you won't be getting questions like that. You will be getting random conceptual questions. Okay, so solve this question and tell me what is your answer. Solve this question, think about this question. What can you infer from this question? What answer are we getting? Answers? B. Okay. So look very carefully what is the question. So consider the logic circuit shown in the below figure. The function f1, f2 and f in canonical sum of product form in decimal notation are. The function f3 is. So you need to find this f3. You have been given the minterms of f1, f2 and f. So what is f? Okay, what is f over here? F1 is, sorry, f is given, it is given that minterms 8 and 9 are present, 8 plus 9. What about f1? So it is 8, 9, 10. I should not be writing like this. F2 is given as 7, 8, 12, 13, 14, 15. 7, 8, 12, 13, 14, 15. Okay. So now tell me, what will be the output of this AND gate? So this is AND gate, this is OR gate. So what will be the output of AND gate? Always remember, when I pass minterms through AND gate, okay, minterms through AND gate, only common minterm or max term will go to output. Common minterms and max term means what? Common input means common minterms and max terms of inputs will go to output. So here you can see 8 is common, 8 is common, 9 it is not common, 10 is it common? No, 10 is also not present. So output of this AND gate will be what? Only minterm number 10. Okay, only common minterms of input will pass through your AND gate and go to output. Okay, note this down. Now what if this is your OR gate? All the minterms and max term of input will pass to output and common terms will be written once, only once I should be writing. Okay, so now look, this is 10. What is the f given over here? It is your what? 8 and 9. This is 8, 9.
So the common minterm is 8, sir.
No, common. Okay, so I have written 10. Why? So that is what I was thinking. What happened? So this is 8. Very good. Thank you. Okay, it should be 8. Okay. So now what I told, that basically when you pass minterms or max term through your OR gate, all the inputs will pass to output along with the common terms only written once. So you can see what, that 8. So this is input to OR gate. So this 8 is coming from here. So the remaining term which is your output of the OR gate, from where it should come? It should come through your F3. So this is your correct option, that F3 should be 9. Only then you will get what? You will get your output as 8, 9. So now let me frame one more question for you. Okay, let me frame one more question, or can I do something over here? Okay, chalo, for the same question. So note this down very quickly, whatever I told. Those of you who have solved, so I don't know if we will be getting correct answer or not. Okay, or else I will frame one question myself. So here basically the function is A, B, C, D, 4 variables. So from 0 to 15 numbers are possible. Okay, so this is F. Even I don't know what will be answer. So tell me what will be F now. Zero, 1. Okay. So look here, this is your OR gate. Okay, solve. So this is your OR gate. So all the minterms are going to pass. Okay, all the minterms and common terms will be written once. So this is M 0, 1, 2, 3, 4, 5, 6. And from here only the common terms. So 0 is common, 1 is common. So this will be 0, 1. And this is AND. So only common terms will pass. So this will be what? This will be 0, 1. Okay. So very simple question. Solve this next question now. See, this is why I told you, look, this question was asked in 1997 and this question is asked in 2008. Concepts get repeated, question doesn't get repeated. See, the same concept question is asked. So that is why I will suggest, if you are from EC, electrical, IN, purchase all the 3 PYQs, okay, all the 3 branch PYQs. And if you are from computer science, so for this particular subject, digital electronics, I will say solve questions of EC, EE and IN. Okay, solve questions of EC, EE and IN. You don't know when your concepts might be repeated. Question is not repeated, but concepts are repeated. So solve this question very quickly. 6 and 8. Okay, look very carefully. So what is given? F is 4, 5, 6, 7, 8. So these are min terms. F2, acha, F3 is given. So where is F3? F1, F3 and F. So I guess this will be F3 and this is F2. Okay. So F3 is what? 1, 6, 15 and F is what? 1, 6, 8, 15. Okay. So now let us see. So this is AND gate. So if you see over here 1, 6, 15. So these are coming from here 1, 6, 15. It is present in this F3. So this is OR gate. Okay. Now this 8 should come from this input. So when will I get 8? If your F2 has 8, then I will get 8 over here. So check the options. You have 6, 8. So if 6, 8 is coming, so what will happen over here? So if this is 6 comma 8, so this will be what? 6, 8. So what will you get? Again you will be getting the same thing, this result. So 6, 8 is correct. What about 4, 6? 4, 6 if you write over here. So option A, if I take 4, 6, so 4 will also come over here. But that is not required. So option A is incorrect. 4, 8, even if we write 4, 8 over here. So again you can see what? 4 and 8 will pass through this AND gate and again 4 will come over here. So this option B is also incorrect. What about option C, 4, 6, 8? So this is also incorrect because you will be getting 4, 6 and 8 over here. So 4 will be again present. So option C is correct. Okay, option C is correct. Now solve this question very quickly. B. Okay, so look over here. The output expression for the K map shown below. So they haven't told you whether to write SOP or POS. So you can take any one of the following. So I am taking POS over here. So because it is simple. If I take POS, this will be the group. If I take SOP, then what will be your group? One of the group will be like this. This is a group of 4. Another will be like this group of 4. So any way you solve, so for this group of 0, if I write POS, so A is common, so A complement, and out of B and C, what is common? C equal to 1 is common, so A plus C complement. Okay. If I want to write for SOP, so one of the group is this one. So this whole group is what? This is A equal to 1. So have I made some mistake? Yes, obviously. This is A equal to 0 in non-complemented form. This is your means 0 means non-complemented. So over here, if you write the SOP, so this will be what? A equal to 1. So A equal to 1. This is one group. Another group is this group of 4. So A, nothing of A is common. Out of B and C, what is common? C equal to 0 is common. So plus C complement. You can see you are getting same answer from any of the way you want, SOP or POS. So option B is correct. Any doubts in this? Any doubts? Fine. So this is the last question for today, and after this I am going to stop, and the remaining questions you need to solve yourself. Okay. Okay, so there is concept of don't care, so that I need to say, so it's okay. So this question will be last. What answers are we getting? So very simple question. So look over here, the output expression for the K-map shown below. So by looking in the options, you can see it is written in your POS form. So we are going to group 1. No one is going to group zeros over here because all the answer is in your SOP form. Shubham is saying C. So if you want to group the ones, so one of the group I can see is this group of 4. Okay, this is one group of 4. One more, this group I can make. So if I start writing, this group of 4 has what common? So B equal to 1 is common, and from CD what is common? D equal to 0 is common. So BD complement, and for this group, this small group of 2, so AB equal to 1 is common. So AB, and out of CD what is common? C equal to 1 is common. So ABC. Which option? Option C is your correct answer. Okay, option C is your correct answer. Now your homework. Homework will be to check the same question using POS if you are getting the same expression or not. Okay. Shubham, D.
So in C, B is a complemented, but we need D
Okay.
complement.
Sorry. I thought you got the correct answer. So this is wrong. Okay, so you can see very confusing options are there. So take care of all this thing. So these are all important thing. You can see it is D. Okay. D is correct. Yes. So C is wrong. Shubham, you wrote the wrong one. Okay. Then you corrected yourself. So always in examination, when you mark the options, check. Okay. So this is your homework. You need to check for POS, and over here also you are going to check this question using your K-map if you get the same result or not. Okay. So today we are going to end the session over here. So tomorrow also there is one class. Okay, from 9 to 11. So we will, in tomorrow's session we are going to cover the remaining topics, whatever is remaining. So we will be ending this chapter tomorrow. Okay, we will be ending the first chapter tomorrow. Okay, so I will